Hello everyone. In Unit 4, Lasers and Fiber Optics, we will discuss the types of optical fiber. So optical fiber are classified based on the modes, based on refractive index and based on materials. Based on the mode, it's classified into single mode and multi-mode fiber. Based on the refractive index, it is classified into step index and graded index fiber. Based on the material, it is classified into glass fiber and plastic fiber. So we will discuss based on the modes. So based on the modes, it is classified into single mode and multi-mode. So single mode optical fiber, the name itself says a single mode. Only one mode will enter into the optical fiber here. So if the thickness of the fiber is so small that is only one mode can enter into the optical fiber, it is called single mode fiber. So as the thickness is very small, that is the diameter of the core is around 8 to 10 micrometer and the outer diameter of the cladding is 60 to 70 micrometer. So the diameter of the core is very small such that only one light ray can enter into optical fiber and get into the transmitted. Next, multi-mode fiber. Multi-mode. Now that means number of rays can enter into the optical fiber because the size of the diameter of the core is around 50 to 200 micrometer. So because of this large diameter here, more number of rays can enter into the optical fiber and can undergo TIR condition here. That is called multi-mode fiber. In the case of single mode fiber, the diameter of the core is very small, whereas in the case of multi-mode fiber, the diameter is very large, so more number of modes can enter into optical fiber. That is called multi-mode fiber. Now based on refractive index. Based on refractive index, it is classified into step index and graded index fiber. Step index, that is, if you see this figure, this is, we have, in the case of step index, we have uniform refractive index of the core and uniform refractive index of the cladding. So because of uniform refractive index, the refractive index is varying step by step from center of the core to the cladding here. That is called step index fiber. So let us say N1 is the refractive index of the core and N2 is the refractive index of the cladding here. So here the refractive index is varying step by step from center of the core to the cladding because of uniform refractive index here. So since the step index profile is in the form of steps, these fibers are called step index fiber here. Okay. So the transmission of information will be in the signals or pulses here. Again, this step index can be classified into single mode and multi-mode here. This is graded index fiber. Graded index fiber is, we have non-uniform refractive index of the core here and uniform refractive index of the cladding. So because of this non-uniform refractive index of the core, the refractive index gradually decreases from center of the core towards the cladding here. That is, it gradually decreases from center of the core towards the cladding. That is called graded index fiber here. So here which gradually falls with increase of radius at the core cladding interface with the refractive index of the cladding. This is called graded index fiber. Now in the case of refractive index here, which is decreases continuously from center of the core towards the cladding here. Okay, again this graded index can be classified into single mode and the multi-mode here. But if you see the graded index in the case of multi-mode here, if you take the core diameter 50 to 200 micrometer and the cladding 100 to 250 micrometer here, then the refractive index is circularly symmetric here. That is, the propagation of the light ray is not due to the root reflection but by the refraction here. In the case of graded index fiber, the light travels at different speed at different path of the fiber. Near the surface of the core, the refractive index is lower, so the ray near the outer surface travel faster than the ray travel at the center. Because of this all, the ray arrives at the receiving end of the fiber approximately at the same time. Now if you see, this is the figure here, graded index fiber, number of rays are entering into the fiber with different path and different type here. Now these are the difference between the single mode and multi-mode fiber. Single mode, only one mode can enter. Multi-mode, more number of modes can enter. In single mode, the diameter of the core is very less, whereas in the multi-mode here, the diameter will be very large, such that more number of modes can enter. In single mode, the dispersion is very less here. There is in the case of multi-mode, the distortion and the dispersion takes place in the multi-mode. Dispersion is nothing but the spreading of light bursts is called as dispersion. The bandwidth is 50 megahertz for the multi-mode step index and 1000 megahertz in the case of single mode. In the case of multi-mode, the bandwidth is between 200 to 600 megahertz, though theoretically it has an infinite bandwidth. Fifth point, numerical aperture of multi-mode step index fiber is more than single mode step index. Here it is very less. In the case of multi-mode, numerical aperture graded index fiber is less. In the case of single mode, the launching of the light is very difficult, whereas here in the multi-mode, it is very easy. Now, let us see the difference between the step index and graded index fiber. Step index is, we have uniform refractive index of the core and the cladding here, so it is varying step by step, whereas in the graded index fiber, we have non-uniform core and uniform refractive index of the cladding here. The second part is the light rays propagate in zigzag manner here. Here it is propagating in a zigzag, crossing the fiber optics and undergoing TIR condition here. This path, this particular zigzag path of movement of rays is called meridional rays here. Whereas in graded index fiber, the light rays propagate in the form of skew rays or helical rays here, which is called skew rays or helical rays. They may not cross the fiber axis, but here they are not crossing the fiber axis. They are in the form of an helical rays here and undergoing TIR. This is called as an zigzag rays. Whereas in the step index here, it is called zigzag path. Whereas in graded index, it is called as an skew rays or helical rays. Thank you.